A very good afternoon to all of you. And we are having this session after lunch, so I think all the presentations will be very interesting, so that you roll doors off. So I think we have a lot of use cases around AI. So it will be very interesting to know from each organization that what new they are bringing up in terms of AI, because this is the next future for maybe power sector, or in terms of India, like our Prime Minister is now promoting digitalization. So we all should also now promote digitalization and move towards AI. So our session for this afternoon is deep dive session on AI, ML and robotics use cases for utilities. So there are several utilities present in this forum who will be presenting more about what they have done in terms of AI, and there are a lot of use cases. So I'll be introducing all of you, because the name tags are obviously there in front of each one of you, but you should also know that who is from which organization. And then the person who will be doing the presentation, I request that speaker to please share your topic, and then we'll start with the presentations. So I'll be inviting, may I request everyone like sitting in back, they can also come in front, because I have the whole sum of speakers, but if you will look comfortable, you can come in front also. So yeah, so are we ready? Can we start? Yeah, I think so. I'll introduce you with the chair of this session, Miss Kiran Gupta, who is Chief Customer Experience Commercial, Tata Power. Welcome, ma'am. The speakers for this session are Praveen Kumar Goyal, sir, who's Senior VP NPCL. Welcome, sir. Then we have with us, Then we have with us Mr. Murthi, Additional VP from BRPL. Are you there, sir? Yeah, welcome, sir. I have with us Mr. Kumar Pabbineedi. Did I spell it right? Yeah. Who's Manager Vizag PGCIL, Power Grid. Welcome, sir. Then we have with us Mr. Anil Ojha, Head Technical Services from Tata Power, Odisha. Welcome, sir. Then we have with us Mr. Deependra Agrahari, who is Assistant Manager, REC Limited. Welcome. We have with us Aftab Alam, sir, who is Head Senior VP IntelliSmart. Welcome, sir. We also have with us Mr. Vivek Kumar Chaube, who is Data Scientist from NPCL. Welcome. We have with us Amit R. Kulkarni, sir, who is Additional Executive Engineer, Mahatransco. Welcome, sir. We have with us Sumit Gupta, sir, who is CEO Asset Plus Consulting. Welcome, sir. Also, we have with us Ms. Vishakha Chavan, who is Product Manager, Impresa.ai. Hi, welcome. We also have with us international delegation, Mr. Dimas, who is Manager Electric Power, PTPL in Indonesia. Welcome.
Welcome, everyone.
We also have with us Mr. Mrityunjay Das, AGM. He's from Tripura State Electricity Corporation. Okay, so he is not joined, then I'll have to call him. Okay, so we'll start in presence of Miss Kiran Gupta, ma'am, who is chairing this session. Ma'am, I request first like your kind words and special address to start this session. Then I'll call everyone one by one to give their presentations. Thank you.
Yeah, of course. I think I would request Mr. Praveen and Mr. Murthi also to join, so that maybe more people from the back side, they can join the front table and we can actually have a very interactive and a fruitful discussion going ahead. So, thank you for making me join this session and chair the session. So, we all know that we have very ambitious targets which are set at the country level, and for the energy goals of enhancing the fossil fuel capacity to 500 gigawatt by 2030 and achieving the net zero emissions by 2070. So definitely with these kind of aspirational goals, there are many challenges also associated to this. But I think everywhere we are actually adapting technology and the digital solutions, and no doubt AI, ML, blockchain, metaverse, robotics, these are also some of the technologies which are being increasingly adopted by different organizations in different sectors and in different ways. So I think as we all by now know and understand the benefits of AI ML, and primarily AI ML, it talks about enhancing the capabilities in three areas, which is reliability, efficiency and sustainability overall. We know reliability with the increasing renewables and all, and the customer expectations also. So reliability is an area which can be improved with the predictive maintenance. Energy demand forecasting, how precise, how accurate we are in the forecast, grid optimization. So I think AI ML has a definite role to play, integrating the renewable energy sources, DER and all, and helping us detect the anomalies in the grid due to the EV and solar usage, which is getting added enormously to the overall generation kitty. Efficiency improvement is also another big area which I think many of us have started using to some extent in our area of work, and this is an area which can actually be kind of enhanced in terms of the efficiency in many folds, the customer experience and the customer expectations, how AI ML it can help us in avoiding the repeat work and actually using the human expertise in some kind of a value add, thus avoiding the repeat or the rework kind of activities which are like repeat in nature. As we grow, I think our resources are getting limited everywhere. So actually we have a need to kind of induct and incorporate AI and ML in every area. So I think going forward, we will have a look at the technologies, and at the onset, I think we all know, and I would be happy to share the examples from the global base as well, wherein we have companies like NL, which have been using the AI technology to a greater extent, and they have been using and benefiting out of this. At Indian level also, we have Tata, in Tata Power, at least I can give one example of Tata Power, where like we have used AI ML as of now, till now also, in many aspects, starting from be it the grid reliability, kind of doing an in-house development and using AI to kind of detect the anomalies in the transformers, how to kind of have the image analytics as a tool which can capture the images of the faulty transformers and then compare it, and actually there can be a self generative model. Similarly, meter installation comes another activity which is kind of routine, and lots of meters are getting installed. So how the image analytics, how to capture the images while we are installing the meters, and we can actually look up to and aim to get kind of zero defect meter installations. So those kind of things, predictive maintenance, enhance customer experience, around I think around 10% as of now, our customer emails and all which come to us, I think, which is also being done by NL. So they are being addressed through the bots. So I think in every area we have AI and ML as a very big use case, and many of the organizations have started using it. And today, while we gather today with all of you, we have many presentations which are kind of as an eye opener. So I think I would request to go to the next set of the things, and which is the presentation, and I would be happy to see, and then we can actually exchange some of the best practices, and we can actually make it a very beneficial and a fruitful session today. Thank you. Thank you.
Thank you so much, ma'am. Thank you so much, ma'am, for giving this conference and session direction. So now I'd like to call over Praveen Kumar Goyal sir, who's Senior VP from NPCL, to please come over and give his presentation. So whatever you're comfortable, if you're comfortable from here, you okay.
I will come over. Good afternoon, everyone. I believe I'm audible to everyone. So, firstly, thank you ISGF for inviting me, and thank you Kiran ma'am for setting the context right. And you have rightly mentioned about the role of AI and ML, particularly in the electricity distribution business. You have mentioned the multiple things. Tata Power is also doing wonderfully good. We have also tried to do our bit. So in this presentation of mine, it is a particular use case which we have to demonstrate as part of the overall scheme of the things devised by the ISGF. But at the same point of time, I would also like to share that we have also done a lot on the AI and ML side. You, madam, talked about this image analytics, particularly for the meter installation. So there, I would like to share that we have also done, and we have gone ahead a step further, and we have used the Gen AI model, generative AI model of it. And particularly, I am happy to share that till now our success rate, or say the accuracy of the model output, is more than 90% for the whole current meter installation. So personally, I termed it as my quality manager, which is deployed in the field, because generally this quality testing is done on the sample basis, 5 to 10%, but here we are able to ensure it for the 100% of the cases. So similarly, we have also done multiple use cases on the RPA side, and my colleague Vivek is also here. He will also share one of the use case in this presentation. Now coming to the specific portion for which I have been asked to give the presentation. It is basically for the GIS side of the business. GIS, as we all know, does act as a fulcrum, and many of the other technologies are dependent on the output of the GIS, for example, ADMS, OMS, energy audit, etc. And for that purpose, continuous update of the land base, particularly in the area where we are situated, which is having a lot of changes in its demography, in its landscape, it becomes imperative for us to really look how those changes are taking place. So as a layman, particularly for GIS, to create the land base, traditionally satellite imagery is procured, and then it is vectorized, digitized, and then it comes onto the play. Here in this particular use case, what we have done, we have used this AI and ML for the change detection purpose, and also how the demography of our area has changed or evolved. So before that, very briefly, I would like to share about my company. So NPCL, it is a joint venture of RP Sanjeev Goenka Group Company and the Greater Noida Industrial Development Authority. Majority stake is of RP Sanjeev Goenka Group. The company got incepted in December 1993, and since then we are serving in our license area. Presently, our consumer base is, though it is a bit old slide, consumer base is about 1.87 lakhs. We have energy sales of now about 3,300 MU plus. Peak demand is 765 MVA plus, which we are hoping that it will touch 860 MVA in this summer. Network length is 7,500 circuit kilometer plus, and the further bifurcation is provided below. We have about, as of now, 62 33 by 11 kV substations. We also have this GIS technology in place, that is gas insulated substations, to really improve upon the reliability indices. We have switching stations also in our area of operation. So on this particular topic, as I have mentioned, this change detection, land base or land use, land cover changes. So it becomes pertinent and important for network planning purposes, for management purposes, and also do a sort of farsightedness. I am not talking about the day-to-day land-based changes, which in any case we are taking care while providing the new service connections, or while say doing the erection or installation of our network elements in the field. What we have observed, that we procured our satellite image firstly in year 2015 and subsequently in 2019, and it is a tedious job. And also when this satellite image is procured, then it also has its own latency, and then further digitization. And it was also we were not in a position to really see how the changes are taking place. So in this particular project, I think I will skip the slides also, or I may continue with this. So what we have done, we have taken the latest image which is available after the, say, sort of deregulation of the various provisions by the government of India, and this latest images are available on paid basis also and free basis also. So we have taken the latest image, and then we used one software by a company named XYZ, and then in that software we processed the images of the older one and the newer one. But before that, what we had to do, we really had to firstly identify the land-based related various objects. So for example, agriculture, water bodies, roads, buildings, vegetation, etc. So those land-based, those objects were identified, and then those objects got digitized, appropriate logics built in the application, and then we trained all such objects through the samples. So initially the sample size taken was about 80 per object, and then subsequently it got increased. So this is the image which I was talking about in year 2015-19 and then 2024. If you will see in the land base, you will not find much difference over here. Though if you will zoom also, it will become very difficult where really the detection, these changes have taken place and how to do the detection. Now, if you see here, we try to depict how the land uses or land related changes have really taken place over the years. So in our area of operation, only one river, Hindon River, flows, so no change, almost no change in the water body except some collapse of the bed of the river. Then agriculture land, as the area is getting developed, so the agriculture portion is getting reduced, and the reduction is in the tune of 3%, and which obviously suggests many things. This industrialization is taking place, urbanization is taking place. Then vegetation reduction is also in the tune of 1% in our area because of the either encroachment, deforestation, or maybe as part of the authority planning. Built up here, it is very important. If you see, it reflects a 9% growth. 9% growth, and also when we go deep down, it also reflects that where really the construction is taking place of the high rises, and where the say development activities are taking place, and where the potential load is going to come. Then barren land, we also see the reduction of 5%. Again, it is for the industrialization, urbanization, commercialization. So what is the use case? We have done all such detection. So really we were in a position to suggest to our network planning team that ideally this should be the, say for example, new substation location. At this pocket or in this particular square kilometer of area, lot of habitation is taking place, lot of industries are coming, and then not only the substation land earmarking is there, but also associated network planning. And it starts from the evacuating transmission substations. So how to feed the incomer of that proposed substations, and how to evacuate the power to the other load centers from that substations.
Sorry, sir, to interrupt you. So you have all.
Okay. Time limit.
Yeah.
Okay. So I will just close.
Yeah.
So this is the use case. Here the important thing is developing the model, after digitization, and then train the model. And this accuracy in any AI and ML project is going to come only after a certain time elapse and after giving a lot of inputs. So this is also the case with regard to our chatbot, which is very much giving or serving our purposes, and the accuracy I am happy to share is more than 96% of our chatbot. So with that, thank you.
Thank you, sir, for sharing the insights on the developments which NPCL is doing. Now I request Mr. Murthi, additional VP from BRPL, to please come and present.
Good afternoon to all the delegates and ISGF team for organizing such a wonderful platform, for sharing the best practices of utilities. In today's scenario, technology plays a vital role for increasing or better planning and efficiency, cost optimization. So demand forecasting is today why we are from the government ministries to the bottommost level of the DISCOM, everyone is discussing what will be the demand for the summer, high demand period, how we will be meeting the demand. So we are lot of discussion is going on. The key thing involved is that demand forecasting at accuracy level plays vital, so that we are able to plan our resources properly and maximize the cheapest resource available in the market to meet our demand effective way at cheaper cost. So I will be sharing some of the best practices what we adopted in BSES. So why demand forecasting is important is, yes, the power purchase cost is one of the biggest component in the DISCOM supply cost. So if we are able to predict our demand properly, so we will be able to also optimize the cost, how we can mix our portfolio and supply to the consumer at cheapest cost. And we also seen that each of our state has a different pattern of consumption. So there is a chance each DISCOM to complement. Somewhere there will be surplus, somewhere there will be shortages. Each one can surplus, and it can effectively, all together can manage better way to meet the grid security. And also there are other levers available in the market. There is a long-term resource tied up by each of the DISCOMs. Apart from long-term resources, there is a short-term markets available. So because obviously forecasting would definitely have certain error, but the error, if it is smaller, it can also met from the other available market. So like exchanges, other D portal available, and we are able to have able to meet consumer demand, means without any interruption we are able to supply the demand to the consumer. Just to share, actually, last 3-4 years, if you see, the patterns are changing because STEM is becoming normal. STEM is becoming normal nowadays because the weather patterns are changing every year. So with a normal human being, if you do the demand generic CAGR based method, it is bound to have an error and you will face a difficulty at the time of meeting the demand. So technology plays important because we need to understand how the weather is changing. Apart from that, how this demand has a complex variability with the other parameters. So though there is a historical pattern available, but the patterns are changing. Apart from pattern change, weather change, and there are new loads are getting added in the on the grid. So we also need to understand the factors affecting the demand, so that we are able to meet or predict the demand better way. just to give the glance, so BRPL is one of the largest utility in Delhi. We are supplying 44% of Delhi. We are meeting 44% of Delhi demand. So the other sister concern BSES Yamuna, so another 20%, and third is Tata Power, and then the other small discoms, two discoms, ND, MC, and MES. So if you see that typically the Delhi load, it varies very widely. Between the day it varies. In a summer, it minimum to maximum it varies 1.5 times. And the winter season, if you see, it varies 3 times actually from the minimum to maximum if you see. And the seasonal variation is so large. Summer and winter, the variation is actually the summer peak is so lowest of winter demand. So the variation is very wide actually. So it is very challenging to understand the normal Excel working actually. So we as a leading discom and we have adopted AML model from almost 2015 onwards, and the AML model basic key data inputs required is the historical data needs to be provided so that the model able to understand, bifurcate, diversify, understand the historical pattern, what is coming along with the weather data, and then the specific key events. So key events means the holidays, and then there is a weekdays behavior is different, weekend day behavior is different. So all those data are fed into the systems so that the model able to predict the history first based on the historical data. Then we generate both monthly, seasonal as well as day ahead, intraday basis the demand forecast. So what it does is basically the model has the historical pattern. Then apart from historical pattern, then the day ahead basis, real time basis, the restricted load, unrestricted load, then the weather data changing. So it fed into the system. So the model takes the changes, what is happening in the real time as well as the what happened in the previously in the historical. And considering those aspects, it generates a better output, accurate output. So if we see typically we are able to reduce our error, so mean average percentage error. So statistical, it is a statistical how the demand forecast with respect to actual. So we are able to reduce our error below 4% level consistently. So this gives that we are our model adapted is working fine. It is giving a better output, and intraday basis we are able to reduce our error to 2% level. And the optimized demand is used for the schedule. So we have a portfolio of over 50 plus plants. So we are able to optimize those resources. So we, in terms of giving priority to green power, then thereafter the thermal powers to meet the demand. So one of the report, Posaka also appreciated our efforts in terms of taking lead and using the AML for demand forecasting. So though we have been using the technology, still we see there are challenges which we need to address because the new loads coming. So we need to understand the behaviors to better predict. So this is ongoing process. It's not ending actually. Though it is adapted, ongoing basis we need to fine tune and learn a lot. So to summarize, so accurate demand forecasting optimizes the cost. It gives a great securities. We are able to reduce our deviations. So we are able to operate better in a real-time basis. So we are able to maximize use of green power, and the interruptions are reduced in Delhi. Thank you.
Thank you, sir. Thank you, sir. Now I request Mr. Kumar to please come and give his presentation, and also I'll be requesting all the speakers to please keep your presentations limited to not more than 10 minutes, because then we'll open the floor for discussions that will not only give you more insights, but also we'll have a small brainstorming session which will be useful for us, because in this we'll are only presenting, but then we'll have discussions also. So I'm starting the timer here, so I'll tell you when it's 10 minutes. Thanks.
Good afternoon, everyone. Myself, I am Kumar. Presently, I am a manager in Power Grid. So in PowerGrid, we deal with all the 400 and some 65 kV installations in India. And I am especially specialized seasoned engineer for HVDC installations. We have 18 number of HVDC stations in India and all being managed by PowerGrid. And HVDCs are a special kind of assets for India where we can wheel 50 megawatt of power in the direction we need from any load center to any part of India. So from 50 megawatt to 6,000 megawatt, we have various capacities, and we are maintaining those assets with 99.80 availability so far. So in power systems, we cannot decide anything based on what we see. We need data all the time to ascertain what is happening in the system. And at the same time, all the utilities rely on the data to monitor, control, and optimize complex power systems like FACTS. FACTS are called like flexible AC transmission systems, HVDCs, STATCOMs, TCSs, or the subcomponents of the FACTS. Flexible AC transmission systems. There is a term flexible. They are easy to see but very complex to operate. So before going further, I would like to share my experience. I joined PowerGrid in 2014 as a costing engineer, and then I shifted my domain from costing to HVDC, and I was a shift operator for 3 years. And our installation was done in 2005 by Hitachi, and I was a shift operator for 2 years. So we don't have any audible alarm to get an idea of what the events are coming within our plant. So I cannot look at the monitor 24/7 to have a overview of what events are coming, what are the faults, what are the warnings and all. So for instance, if there is any tripping or if there is any mal-operation, I had to scroll back around 200 to 300 events to get an idea of what went wrong in the system. So to address these difficulties, we developed a OCR based alarming system. And the background for this system is like after COVID, when I am traveling to my hometown from Hyderabad to Kakinada, I got a speeding ticket. I was going at around 120 kilometers per hour, and still RTA department able to capture my car, and they extracted my license plate, and they have sent me a challan within 5 minutes. So they are using a technology that can capture fast moving events on a screen or any image. So we took that. The concept behind our OCR system is like we capture what is happening on the HMI, human machine interface, and we process the images to extract the text, and then we will feed this into a large language model, which is Gamma 3 presently we are using, so that we will get some insights about what are the events that are coming and how frequently they are coming, and how we will get insights about the system. So since our system is installed in 2005, we have very limited support from the OEM, and the technology is very complex, and part of the system is very outdated, and we cannot upgrade because the minor upgrade of a HMI costs us around 3.6 crores. So simply for observing the events, we cannot upgrade any minor part in the larger system. So our approach for the OCR based alarm system is...
Can I request to be a bit louder, please?
Yeah, ma'am, sorry. So our approach for the alarming system is like we will capture whatever is happening on the HMI screen. We will convert all the data to a text or a CSV file. We will maintain a database. Then we will feed this into a RFC learning model, and then we link this to a LLM, large language model. So then from that we are extracting the data we need and the analytics, the trends and all. So if we look at the flow chart, it is not so clear, but I will try to explain. So can I have the pointer, please? Pointers. Yeah. So initially we will capture what is happening in the HMI screen, and we will convert into a text-based format. So then we will analyze it for the keywords with our experience, like tripping, high voltage, low voltage, faulty. These are the common keywords that happen in a power system. Then we will feed this to a RFS model, and it will train itself over a period of time. Like we have 20 years of data with us, so we trained that model, and we have given these trained data sets to a LLM, which is a large language model running in our local machine. So it will further process the data, and it will give us fine analytics. So this is the architecture we have developed. So initially we will capture the data using a Raspberry Pi camera, and we will use OpenCV and Tesseract OCR to extract the text out of it, and we will maintain a local database. So then we have a local AI model, trained model, where we will get historical alarm data. Like if a motor is operating for more than a threshold, like we commonly, it is acceptable for a motor to run for 24 hours a day. No, sorry, 2 to 3 hours a day. But if the motor is operating for more than that threshold, maybe there is something wrong with the hydraulic circuit or some other part down the line. So as a shift operator, we cannot look at those events 24/7. But if a computer is located, and if the task is given to a computer, it will never miss such an event. So we have a model, we have a trained model there, and in terms after the training, we are, whatever the database we are able to generate, we are giving it to a LLM installed in our system. So it will give us a real-time insights of what's happening in the HVDC. So if I can play this, can you please? So this is completely developed in-house. We are not dependent on any other third party. So we developed the complete hardware, and we wrote our own codes, and we trained our own AI model, and we integrated into see, this is the small camera that is looking at the HMI, and these are the live analytics it is generating. There is an event generated, there is a pump that is running, when the pump started, when the pump stopped, like that. So all the legacy systems that are very old in nature cannot be upgraded. And whatever the 61850 kind of systems, the kind of analytics we are getting from the system can be adapted using AI and ML to the legacy systems, so that our operational experience and the asset management will be easier. Thank you very much.
Thank you so much for sharing the insights on from PGCIL. I think since government has now started taking the initiatives, and we see government bodies also taking good initiatives in AIs, we see a bright future ahead. So now I request Anil Ojha sir from, he's head technical services from Tata Power, Odisha. So I request him to please present his, and sir, I'll start the timer.
So good afternoon all. I'll try to make a crisp one, and thank you for this opportunity. So as the session says about the AIML, and my project is again related to the load forecasting in western part of Odisha. So just give a short glance. We are just a 4-year-old utility. Started journey in January 21. We have spread across 50,000 square kilometer area, covering peak demand of approx 17 to 100 to 1500 megawatt, and this is spread across 9 districts with 5 circles over there. So before I go to, I just put this slide, and it has a correlation with our own load forecasting. So when I say it's a India best kept secret Odisha, why so? Because it is a tagline of Odisha tourism. I have taken from there, and there is 3 things is very you may aware, may not be. Hirakud Dam, there is a temple is known as a Huma temple, which is more than 4 times linear than the Pisa Tower. And third, which is recently created in 2023, is our hockey stadium, which is the world record in terms of the sitting capacity over there. So I thought to put it all this because it has a relation with how the load forecasting is parameters. So if you see the trend, particularly, it's a very different segment because if you see this load growth in all 4 years are different. And similarly, if you see the trend, which is in terms of consumption, has been fallen from 1063 MU to suddenly 728. It is because this nature of the load or the category of load over there, what we serve over there, the consumer, which I am going to discuss in the next slide. So if we see this last all 4 years which we have started operation, so the good part that we have approx 55 to 54% of consumer base is industrial. Though it's a good in terms of getting a revenue generation, but it is giving a different kind of set of challenge when it comes to load forecasting activities. And if you compare with this 55% with the commercial and industrial, it is going to approach 60 to 65% case where we have that mix on that part. So the customer, I'm just sharing one, the consumer who is Bhushan Power, who has city of 200 megawatt, but this is just a 2 days to 3 days back data, where every slot there is a variation, and the slot variation is happening from, and there is 90 slot variation is happening, which is 166 megawatt to 0 megawatt. Because the nature of the job, nature of the activity, they perform at their end. And many of these partners have their own CGP. So it's very dynamics that they can opt open access sometime and then use our own power for that activities purpose. Similarly, this is Vedanta, which has again variations related to approximately 100 megawatt in slot wise of data terms. There is one steel plant, Rourkela steel plant, which has their, we had CD with 250 megawatt, 170 MV earlier. Now they had installed their CGP. Though if it start taking the care of the last pattern data analysis, that may not be need to be abstracted from there. So these are the kind of challenge which is going to pose when you talk about related. Though there is a bulk consumer have a good percentage of total data of there, but it is creating a different kind of scenario for the making this prediction more accurate and then other parameters. So suddenly if you see the terms, this energy is going to reduce every year in terms of Vedanta. Though the total demand of MU are increasing, it means that there are reliability parameter, there are other segment of consumers are feeding to the network which is increasing the energy cell over there. This is just a load curve that how we train the model, and we try to develop in this scenario that how we can bring the local phenomena, because this is all, if you see particularly forecasting is cannot be a global scenarios. So we need to understand that how we can use, we had further taken this all 3 major events like Deepavali, Holi, and there is a local phenomenon happened, Nuakhai, which is local festival of Odisha over there. So while doing this time series analysis, because data are in the time series based, so what we did, if you see this color in the green mark, is we have tested so far where the model is designed. Other we are going to have a multivariant parameter need to be tested further, because there are impact are externals like changing on open access is a scenario. We don't know that how it's going to happen, but it depends on the coal price linkage over there. So we're trying to build that how the coal price variation are affecting the my consumer, that because they may opt the open access in 4 to 6 blocks over there. So we are trying to build that one. So multivariant things we are going to build over there, but however we had started univariant, and that model we have tested in the scenarios. So I'll really have used the same methodology of deep learning, where we try to model the 20 different algorithm with the help of and I forgot to mention that one more thing, that what we did in this, because we are local established there, we had tie up with our one of the university called Sambalpur University, where we had took the professor for having the more analysis on data, because we understand the domain better. They understand that their own AIML and deep learning parameters. So try to have combination that how we can bring more activity related to on that part. So what we did the complete testing in the 15-minute block to forecast the next variables. Similarly, we did for the 1 hour for forecasting the activities, and further we did for 96 blocks. So all these 20 models have been tested, and we found that linear regression model was helping us in all 3. If you see the segmentation like RMSE value, map value, and MAE value over there. And if you normally we do the map error finding over there, and you find that as of now, even though we had used a single variant, the variation is coming 4 to 6%. So there are opportunity we for have to use this technology for the purpose where we can bring this activity and model the scenario in such a way that it can help to boost our the activities also. So on. So if just give a take away that part. What is that? Having that, though the DSM is going to come because in Odisha, the state, there is a company called Gridco. He knows the all power purchase as of now. But if it comes to discoms, it is going to be challenging scenarios related to how they are going to manage their block and everything over there. Second, that parameter is going to bring that, even though because last speaker has mentioned that how the importance is the known the data on the real-time basis. So similarly, for the load forecasting is going to be one of the phenomena that how the correlation and between the big customer, even though smart meter are coming, that a small customer rooftop is going to be real-time basis. The data exchange of information is required to predict the activities. And the last, which is basically geoeconomical scenarios of any state or any particular area where we want to do the forecasting is going to impact over there. So it is all three are the required to be forecasted in such a way that we can predict and correlate the data for the having more than testing and using the techniques those are available for the load forecasting and other parameter activities. So thank you very much.
Thank you so much, sir. You have not only shared the challenges but also solutions as well, which is very important. So now I'd like to call upon Mr. Deependra. He's from REC Limited. I request you to please share your use cases, and you have 10 minutes.
Namaskar. Good afternoon, ladies and gentlemen. I hope we had a good lunch today. So I think everyone is... It's okay. I'll try to make it a little interesting. So first of all, I would say thank you to Mr. Kumar. Before I proceed, I just tell, before REC, I was in Power Grid. So thank you, Kumar, for just showing this presentation. And today I'll feel proud I was on that particular team for that AIML. Thank you so much for that. And when you are sitting in the corporate office and you are doing a lot of developments, but you never actually estimate what substations are facing the problem over there. But when you gently give the solution to them, for us, okay, sitting in the corporate office, telling that, okay, go to the 2 kilometer there and check the anomalies. It's very difficult for people to go there. But yeah, sitting in the office with the AC building, it's say too easy. Oh, go there for 5 kilometers and check whether anomalies there are not. So thank you so much, Kumar, for giving us presentation. It helped a lot from my side. Like I feel proud today. So I was on that team. Let's move forward. And I just showcased some use cases that REC has used in terms of AI implementation. Especially in generative AI, we have done few things. So I just quickly say REC is one of the Maharatna company. And we are basically NBCC, and we are just doing the funding in power sector, and now we move to the non-power sector as well. So we have a total around 5 lakh crore plus loan book, and I won't go much detail on the finance side, but yeah, finance side we have to talk because a lot of things we have done in AI in the finance part itself. So our balance sheets and a lot of data. Honestly, I'm very weak in finance, but yeah, when I just trained my models in AI, so on that time I fed a lot of documents from past 15 years in REC, like whatever the balance sheets and other stuff was there. So few were in the proper soft format and few were in the just hard copy and all. We fed our models over there and we just put the data over there, and very beautifully insights we are just getting from our models over there. But be a crisp, like few of them, not like a machine can never touch a human brain. So I'm getting a result from the system, that's good. It will helping out to eliminate the errors that definitely a naked eye can sometimes missed out. But yeah, end of the day, we need to verify all the checks what we are getting, especially when you are in a finance. So you have to check all the stats. So I'll just quickly through around what are the projects we have done it over here. So as a nodal partner agency, we have a lot of government schemes that they used to support. So in those schemes also we have implemented. Recently we have PM Surya Ghar Muft Bijli Yojana. Over there we have implemented few of the AIR model, especially for releasing the subsidy. We got a alarming situation over there, especially when Modi ji was visiting in around November 24, near to Diwali time. So we had a very challenging situation. We had a lot of subsidies was pending to be cleared. So my ED sir told, like, what else we can do? You guys are in IT. What you are doing over here to just pay it off? And I would say, in India, the customers are knowledgeable. I would not use the word they are not illiterate. I would say they are literate, but they are not doing the things in the correct way. If they would have filled all the forms and everything in the correct manner, so to release those subsidies will not be a much struggle for the operators. So we had implemented some models over there. All the checkbooks are there, what people will attach. So from that checkbook, we convert into OCR, we take some data, we'll try to verify from our system fed. So somehow over there, operator used to take around 10 minutes to pass one subsidy, and we try to reduce that time in our new portal. It's around 1 hour, 1.5 minutes, not more than that. And still, it again 1.5 minutes, depending on the person, how he has uploaded his document. If he has uploaded a proper scanned copy or a proper normal photo he has uploaded, our machine is able to pick it up. If you have entered like something like this, then we can't do anything, because a lot of tampering is there, so machines also cannot read that. So I'll just quickly go further. I put the timer, 5 minutes is done. Oh, have to be fast. So we have done a lot of generative AI implementation. So we have done in the partnership with Microsoft, we have implemented 2 projects. Especially, I would say we are in the business of funding power sector and non-power sector. So whenever a company will come to us, they'll give a detailed DPR. Sometimes it's 100-page, but sometimes 1,000-page as well. So for a person who has to read 1,000 pages, it's very difficult for them. But end of the day, your job is you have to do that. So what we have done, we just fed into our models. So we have developed few use cases. Over there in a background, we have used a Copilot. And over there, what we'll do, we basically take the data, the DPR, like the loans, like what the person who is just won the loan, who has shared with us, will fed into there. It crawl all the databases, whatever we have in the past about their ratings and all. And somehow we try to put a summarized sheet over there. With that, a management can take a call. But still, before, like after creating that sheet, still human intelligence is required. The people have to verify, because end of the day we say IT is not responsible for any discrepancy of the data. To be honest, why should I take my risk? I don't want to lose my job also. So like we have again a disclaimer, like it's your call. I have fed it out this data, and it's your call whether you have to follow or not. So we have done a lot more, like we have reduced the time for DPR evaluation. Honestly, I have sitting with those people, now they are telling like we are able to do within 2 or 3 days. Earlier they used to take 2 weeks, 3 weeks to just analyze all the data. And the best part is, like, see, to be honest, a lot of people will come, they'll just share that same DPR to n number of financiers. They're not change the data itself. They just send it. So our model is able to just give what are the insights that is not according to REC. So that kind of things we are just getting the benefit over here. So a lot of government schemes and digital transformation we have done. We established in 1969. So we have all the soft copies over there, and we have done a lot of analysis with that also. So we just metadata, a lot of things we have analyzed, and we just put into our document management system. Definitely, when you come to the AI, definitely the automation will come into the picture. I won't take much time in the automation part. But yeah, a lot of repetitive tasks can be eliminated, especially for this. Yeah, this photo yesterday only I put. In this, I have seen a lot of people are discussing AI will do this and that. But end of the day, I have to put my mind to just fix it as sun. So any model, any machine, any AI, whatever you learn, whatever you see in the market, you have to feed them. They are learning with us. We have to be a part of the ecosystem. That's all I would say. These are the just key benefits, like faster report generation, especially for the DPR side. Project evaluation, definitely we have streamlined. Manual effort definitely reduced, especially for the documentation part. That's I talk about DPR evaluation. So AI has played a very vital role, especially for our DPR evaluation committee is really replacing for her. I just say recommendations. It's just a common recommendations. It's not about REC. All the company has to somewhat, they have to be follow some AI, because I would say we have to be with the, it's not all about government organization or private organization. It's about you have to come with the market and have to compete with everyone. And thank you so much for listening to me. Thank you so much.
Thank you, Deependra. Now I request Aftab sir he's head senior VP of IntelliSmart. I request you to please give a presentation.
Good afternoon to all. Hope I am audible to the person at the last row. Thank you. So, my name is Aftab and I represent IntelliSmart Infrastructure Private Limited. We are one of the biggest MISP in India, and we have been doing a lot of digital smart metering work. We call ourselves as a digital infrastructure organization, and I will take a brief in-depth analysis, a bit of a few use cases related to customer to network. So, what IntelliSmart is recently started to work on a journey that is going to be related to customer to network. We have been so far focused on customer to meter, meter to customer, and so on. Now we want to embed this AI ML part into our customer to network. Now this whole ecosystem that we see over this particular diagram that we are working upon as an IntelliSmart, we are working on the various use cases where we have a lot of EV devices coming on our network, lot of DERMS devices coming onto our network, and how we are going to manage, optimize our network, how we are going to control our grid, and ultimately how we are going to give a better services to our customers. So that's the overall objective that IntelliSmart has started with. Now, first we will dissect a bit on the network intelligence, how we can have a better network intelligence. So I had heard a lot of our DISCOMs partners all calling about that anomaly detection, predictive asset failure modeling, and load forecasting. So yes, we are already working on those journey where we can provide this solution to our DISCOMs. And we are already present in 6 states, as you are aware, and working with the various state DISCOMs. So in-house, we are building and working on this solution so that we can provide them as a services to our DISCOMs. Right from the AI-powered anomaly detections, which will help us to reduce dependency on manual decisions. So that's the important thing. Next is asset failure modeling. Now, we have a lot of asset. We are supposed to install almost 3.2 crores of meters across India. So we ourselves are having a lot of assets. So this is one of the use cases that we are working to detect the anomalies out there, how we can be going from a reactive mode to a predictive mode of a maintenance, because we have a long span of almost 7 to 10 years to maintain them. So this is another use cases that we have been working on. And obviously the load forecasting for our grid optimization is where we are trying to balance the supply demand scenario. Now our future is all about renewable and EV, right? So on our networks, there is going to be a lot of storage devices, lot of EVs coming in. So far, we are thinking our electric vehicle as a source of consumer. The future I am going to say is it can be also serve as a source of a generation. When the demand arises, it can serve as a generation platform also. So that's what we are working to have a both ways of a communication and provide a grid optimization layer so that our grid doesn't fail the sudden need. I saw somewhere the curves, right? Suddenly the demand is rising, suddenly it is coming up. That's optimization we are working to have it balanced with the help of a AI/ML. Next is grid. How we can make smart grid. We have been hearing this terminology since almost now 10 years. Smart grid is smart grid. Now, grid can become smart only when it is AI/ML enabled, because there is so much amount of data that is not going to be done by a normal software. It's not possible at all. So to have this huge, humongous amount of data, which is even lying in our data center, that how to optimize that, that itself needs a AI. And that's where the generative AI also is playing a very key role. So we have also started and embarked on a journey where we are going to see these 3 important use cases that we have mentioned out here, like grid resilience enhancement, how I can enhance the grid resilience, that particular use case we are working upon, and how we can provide more insight for our control room. The people who are actually sitting in a control room somewhere, how they can get a better insight of the grid. So that particular use cases also we are working upon. Next is related to renewable energies and electrical vehicles. And I heard some of our speakers telling about the weather conditions and all that. So renewable energies like solar and as well as the wind energies. Now there is a lot of combination and factor like a GIS showing you the complete data of our locations, weathers and all that combination, how that can help you to combine those data and predict that what will be my generations. So that is another use cases which we are working upon. Now this is for does and don'ts. This is an important thing that we need to understand, because ultimately, let's say down the line, 3 or 4 years down the lines, if our storage system or the electric vehicle consumptions, basically the energy resource systems increases drastically, because everybody is now putting out some kind of solar panels. So, and it's going to increase as part of our government initiatives, it's going to increase. Now we need to be prepared. Our network needs to be prepared to consume those and to route it to the right direction and right channel. For this, we need a better grid congestion mechanisms, so that this stability is improved between the network and the grids. Now, for this, we are embedding AI/ML, and this is again Gen AI driven models that we are trying to work upon, where we are going to do a predictive analytics for the renewable generations, like based upon, let's say you have a solar, wind, and based upon the weather data, based upon the GIS data, you can predict that what can be my generation out there. Similarly, we are going to use this model even to have secondary or ancillary services like frequency regulations and voltage support, which we are still working upon. Now, out of this all, from the network as well as on the grid, what is ultimately for a customer, right? So as Kiran ji mentioned that there is a lot of things for customers, right, ultimately. So we need to add value to our customers. And that's the ultimate goal to achieve that. And that's where once we have bifurcated on the integration side between the grid, network, then we are focused on the customer service. And that's where we are trying to embed into our customer services softwares the way how a customer calls, that whole experience we need to change. When a customer calls right now, they are required to state, hey, I am having this problem. Why? I have all the data, right? In my system, I should be able to predict that what these 3 might be the problem that he is calling for. Whether he is calling for a high bill, there is an outage in his area, or there are some other problems. So this is the kind of innovation that we are trying to bring in and embed into our customer experience softwares. This will actually help to reduce and equip our customer sales representatives that they can take better care of their customers. Apart from that, having a bot, and everybody is having now a bot in our customers. So I think Impresa.ai is one of the product which I had also worked earlier at my previous organization. So that is also AI enabled. So similar kind of a product are going to come up. But we need to embed the intelligence which can help our customer representative. They should be enabled to talk to our customers in a better way with more accurate data. They should not see, okay, I need to go to help desk and then find out what's this is the problem, I need to solve this. It should be all predictive with a single call from a customer care. So that's the area we are trying to work and try to bring a more better services to our larger audience. Thank you. I think I'm done.
So I think we had around 6 presentations, Disha. So we thought of having a bit of a change in the plan, which was, and perhaps it would be good to have a 10 minutes exchange. As of now, we can have this 10 minutes time utilized for having a discussion on the 6 presentations which we already have, so that we do not miss out on any of the important aspects which we are there in our minds. So I would request Disha that we can have this kind of a slot, and then after the 10 minutes, we'll again go back to the presentations, and we can have the balanced presentations. So I think it was really nice to hear from everyone, and we can see that there are lot many opportunities and lot many areas, whether it is demand forecasting, what we heard 3 times of the change in the demand TPWDL. So I think each one, as I shared in the beginning, each one of us is well aware of the fact, well conversed with the benefits which we can get out of AI and ML. And having heard them, I would request the participants and the other speakers, or whosoever is everyone in the hall, to kind of put up their queries, their questions, so that we can have a good exchange and we can actually make it more effective, and we can scale up on these use cases. Yeah, thank you. So I think Disha, if you can just help in sharing the mic to
Thank you again, presenters, for your experiences. One broader question.
I request you can just open the mic, and also I would request if you please share full name and the organization as well.
Rishabh Jain, National Renewable Energy Lab. I wanted to ask a broader question. When you are using
Louder,
Gen
please.
AI tech,
louder.
or louder.
Yeah.
When you're using
Yeah.
generative AI technologies in your organizations, how are you addressing the problem of, or how are you addressing the problem of using data through cloud-based services versus maybe are these solutions on-prem, as in do you have the models, do you own the models on your services, or do you use a cloud-based service? If you're using cloud-based service, how are you addressing the personally identifiable information which would come as a part of that transaction? Thank you.
So is this addressed to somebody specific, or it's
No, I mean broader, because Aftab ji and then Deependra, I mean I only was a bit later in the panel, so I
Okay.
heard their perspectives, but I'm sure others have also used AIML in their own.
Sure.
Yeah.
So yeah.
So I'll try to answer. I'm sure you guys have. Yes, sir, please do. Yeah. So for the customers we are working, they want on-prem models. So they don't allow us to use cloud-based models. It has to be a hosted model for them.
Yeah, I just wanted to add one thing. Like when we have to deal about especially this data kind of a thing, either my model or my anything about that. First thing is it's about my business, right? What other NBCCs in terms of REC, I'm just telling. So whatever the model or things we had developed, though in the backend we have in like Microsoft Copilot is there and some other technologies also we'll be using. But end of the day, we are bound to that. My data will be there in my tenant only. So we can't share outside. If we start sharing that, then end of the day, my DPR will be floating in this internet, like whatever we have analyzed. So nutshell is like whatever the data we use for this analysis, even in PowerGate, what project we have done, everything is there inside my premise only. We are not at all sharing outside. Because we have to just like, we are answerable, right? Like if data is just going outside. See, there is simple thing. Just simple, I'll just add this way. I don't know who is coming from this gate. I just put a lock over there. Simple. I was in a defense in my earlier stage. Over there they have a network called Anurag. All systems are in a LAN itself. Whatever the research you want to do it over there. Exchange over all the DRDO labs. If you wanted to use the internet, you have one system next to sitting to you. You use that system to just surf the internet. Simple. I cannot restrict my hackers to come inside my periphery. It's better to just make a lock. So whatever things we are using, server all are these servers and all, everything is in hybrid only. There is no internet access, not at all. Like we just do that way. That is my personal experience, I would say. Yeah, correct. So Microsoft Copilot, we have just sit with that team because we have a very limited IT pool in REC. So with them, with those people and with our expertise, we just made a model. So over there, whatever the data is there, that's there. Like we have built a server over there inside in our data center.
Great.
So that way we have done.
Very good. I have one comment.
Yes,
to make.
sir.
Take it as a question or comment.
Yes,
or
no worries, sir. Yes, please.
Input, or let's say sharing some experiences.
Yeah, sure, sir.
Kiran would endorse me on that. See, one of the things I found was that AI was present in some form or the other every time, right?
Definitely.
So whatever, I mean, if you say science versus art, science is something where, you have a question, the answer will be the same. And ask that question 1,000 times, answer has to be the same. So that's what is, okay, a logarithm ban gaya hai, 1 plus 1 is 2.
Then every time 2 is
So 13 plus 13 is 26. People used to say 13, 26. Now you have a computer. And then there's an art, which is difficult to acquire intelligence. Now, one other thing I want to tell you, if you agree, stop using the word artificial. It doesn't look good. This artificial intelligence is acquired. Who has given the intelligence to that tool? We have given.
We only.
Humans.
So it's
And our
acquired.
models.
It's called acquired intelligence. It's a much better term to use when you're actually applying it in your systems. Anyway, that's just my own feeling, and as maybe a copyright I will claim tomorrow. Second thing is that whatever AI solutions that we have, this will speed up work. But we are in a regulatory environment. You may be talking to generators, you may be talking to, but when it comes to ultimately paying for it, the customer has to pay for it. Initially, you might say bank ne loan de diya, no problem. But who's going to pay that bank loan back? The consumer. You can't ask the consumer to pay everything on the capex. You have a power plant and you say, please, Mr. Consumer, please pay 2 crores today because your share is 1 by 2,000 of this power plant. It has to be paid over a period of time. So like that, whatever improvements we are doing in power sector, there has to be a rate case. And somebody has to grill us. Why this and why that? Is it a means or an end? If you think this is an end, then there's the end of the industry. It's good to have, fine. But will it be a tariff neutral spending? Or will it improve will it save money? If the cost is going to be less than what it brings in terms of savings, sometimes you may quantify customer experience and customer delight to be also some quantum. Do that exercise. Now I'll tell you a few examples of where you may have actually gone up to that level. So for example, we have a demand forecast. I remember in Tata Power, we had reached 99%. Some Norwegian company did it. So we didn't even know what they're doing. Okay, boss, this is like a success fee based, how they were doing it. Now we are trying to understand ourselves how we do it. Now suppose demand forecast tells you correctly, and then you have sudden spurts that also it tells you correctly 20 minutes before. What next? I think you should next do something which you would automatically do if you are told, Anil, the demand is going to go 100 megawatts niche hone wala hai. What is your next action should be also built into the last mile of the AI. Please connect with the exchange directly or scale down. If you have a captive plant, you scale down, you have a PPA, you have a 20 minutes sort of a leeway possibility, do whatever. In 15 minutes, you cannot use the benefit of what you get from the response. The only benefit is, I knew this will happen. It happened. But how did you save the money? Because unless you have the entire milestone, last mile of the AI tool giving you that outcome is halfway through. I had done we just did investment on a wind power farm of about 700 megawatts in my previous company. So the SCADA system was done, you know, all those usual people like you, SCADA. So I said, boss, what am I going to do with this? Oh, every information is there. What do I do with it? No, sir, you can plan. I said, no, please plan. So, you know what we did? It was a dream. Let the system find out the faults, decide the best time that it can be repaired, depending on the low wind season, and then communicates with the vendors who have already configured, shortlisted with rate contracts. The system will throw to the CEO a purchase order. That's it. He may want to go through, what was the need for it? No, this is the machine learning part. You know, you will have 2-3 times the purchase manager will say, no, but this is not done properly. Then somebody has to go and say garbage in, garbage out. Who put the garbage? As you were saying. Okay. So the garbage will be cleaned, but the algorithm is, sorry, I just need 2 more minutes. So there the orders used to be, so the action to be taken by the AI ML tool, the human interference should be only approved or not. If you leave it to the guys, it will never happen. You have your REC, AI helping you in assessing DPRs. Fine, you give the loan. Why you give the loan?
No.
After that, you will give the loan, right?
Sir, DPR, I'm just showing the executive summary. End of the day, person has to...
Why are you defensive? It's a good thing. Please use AI to see whether the funds are being used as envisaged in the DPR or not. Otherwise, that AI is only to give loans faster, but whether the loan which was going by at a speed of 1,000 kilometers an hour went down the drain. So I'm just giving you one suggestion on what AI should then continue to do, to look at when the approval that you gave, whether the monies were used for that or not, and do a loop-in-loop. That's all is my suggestion. That's it. You are able to then, you're not a regulated entity, because you put all your cost on the borrower. You know, 12% bhi jayega, 13% jayega. All your borrowers have no way to go. You know, you have to, so, but the guys who have to pay for the cost of this through the tariffs, the regulator is going to ask you questions. It is not easy to just make a business case. It's very easy to make a use case. A use case is, I can taste this tea from a distance. How much you will pay? You will pay, fine. But if that somebody has to pay for it, you say, how does it benefit you? So you have to create a business case in terms of numbers. As to this is how it will save money by X investment, whether it's over 5 years, 6 years, whatever.
Sir, just to add to your point, if just to see, there is a AI is going to bring the intelligence only, but there is another phenomena which is required, like process automation. So process automation. So whatever process we are doing for a segment of, say, reliability improvement or a power purchase improvement, and then there is a customer segment is there, like your call center and others in there. So all thing has to become.
Yes, please continue.
You have done a demand forecast. Now, if your AI tells you that, Mr. Ojha, what would you do if you were present in the office? If you suddenly see part in the demand, or what would you do? Then the system either it will initiate a demand response. Guys, power is expensive.
Yes.
Demand response. Now, sir, Praveen, ask Praveen.
Sir, that is where now the next step is, that's where everyone talks about AI agents coming in. So there is a AI sir says call for action agents, which are AI agents, take it over. I think RPA was used for some time, but now they are talking about agent, and I think there is a lot of work happening already. Where what sir is saying is that takes the next step. avoids that manual work and puts it in a stage where it can be approved. Yes,
Sir,
what
I'll
is-
have to cut you all in between because
I
we are
think,
over.
I think I would like to just add in, I mean, what Sir said, that is really good. In this, I think I also read it somewhere. So definitely AI ML would help us reduce the repetitive work and it would increase the efficiency, right? But no doubt AI and ML, it is we which are who is feeding in the data. So definitely by all means data quality, what I think the point was coming out. So one has to ensure that, otherwise it's a garbage in, garbage out. I think I also fully agree to that. So data quality has to be ensured at the first level. Secondly, I think the human intervention, 80% of it could be done by the machine. But again, final call has to be taken by the human. I think you all would agree, and we all are doing as we shared in our projects as well. And so that second part, second element of a human feedback or a human value add has to be there. And third important factor, which I think he was also trying to bring out, is that after having used it on any business, portfolio, we also need to ensure that it's a continuous learning. So whether, for example, taking the example of your DPR only, or maybe the demand forecasting. So if there is a saving, so like how before, I mean, whether I'm getting a forecast, accurate forecast 7 days before, or it's a 4 hours before, can I actually use that forecast? So that another leg is also very important. And a continuous improvement. So if there is a DPR like which is being evaluated, so whatever data came out of the AI and we used it, so how effective it was. So I think that continual improvement to those use cases, that is very much required. So I think these are the some 2-3 aspects on the data while we start using the AI ML and have those use cases. So we need to be, actually, I mean, we can't just apply AI ML and just leave everything to the machine. I think that was the point precisely which was coming out, and I think that's what we also, I think all the presenters have covered. So with this, I think can we continue to the next set of the presentations?
Yeah, because we have still more presentations to go,
Yeah.
and we have limited time. So now I request Vivek Kumar, who's data scientist NPCL. I request you to please limit it to not more than 5-6 minutes, because now we are running out of time.
Very good afternoon, everyone. Thank you for this opportunity, IGF. I will try to be succinct and to the point. At NPCL, we are on the front runner of adopting new technologies and innovation solutions. Gen AI, recently we have been taking over. But some problems, business problems tend to be solved using traditional machine learning algorithms. That's what we have done in this use cases. So since the post-COVID era, we get to know that there is a slight changes in the payment pattern of the domestic consumers at our supplied area. And we try to provide a custom tailored solution to that using machine learning algorithms, traditional machine learning algorithms to be precise. So not only that machine learning, we try to incorporate those machine learning model solutions and outputs into our ERP solutions, which is S4HANA, such that the end user of this particular credit score output could be used by the customer center or at the customer care offices to provide solutions related to billing, related to supply based on credit scores. Such solution could be implemented. With this solution, we get an accuracy of around 94%. We use many traditional algorithm. I have seen one of the presenters using machine learning algorithm in demand forecasting, using from linear regression to the high-end neural networks. We do use this algorithms. We finally get into selected using XGBoost, trying hyperparameter tuning for that, and finally a solution which provided a custom tailored solution. With that particular machine learning model, we get a solution of we reduce the temporary disconnections of our consumer by 7%. Not only that, but the customer cash recovery from those consumers has been increased by 8% on a month-on-month basis. We have implemented these solutions in 2024. Since traditional machine learning models need to be updated time to time based on new data entries we have. So at this particular moment, we have an accuracy around 97%, though it is used only XGBoost machine learning models. We haven't got into neural networks. As we go into internet, we tend to go towards more high-end network, which require high computing power, high data availability. Since we have the total consumer base around 2 lakhs, so we find that the neural networks which we can use is very limited. That's why we go for XGBoost. This particular use cases generally is not utilized in utility industry. In the context which we have used is here is in utility industry we tend to add payment as a reactive process. Once the payment has been done, once the billing has been done, we tend to wait for whether the consumer will gonna pay or not, or whether the due date has been passed, and then we take a particular measure. We have to go for TD or go for regulatory norms and wait for PD. But what the responsibility for the utility to do? Utility, after just invoicing or billing, we tend to provide we use those data and tend to provide a forecast whether when the particular consumer gonna pay that particular bill. We use that. We collected from the data from the post-COVID era, since the COVID disrupted the payment pattern of most of the consumers. We take the data around after the second wave of COVID from 2022, and we pinpoint the prediction whether when consumer gonna pay their particular bill and at what amount, at what the threshold of a particular consumer threshold amount is. If let's say a particular consumer whose bill is around 4,000, 5,000, and he's going to pay it at a constant rate before the due date. But when the particular threshold goes against 7,000 and 8,000, the consumer tends to have a double mind whether we wait for the due date or after due date and wait for a temporary disconnection. In the meantime, the consumer loses 1% discount, which most of the utility offer. So this particular losses from the consumer, and not only for the consumer, but our end, we lose a particular opportunity cost. Every money which we consumer have used, we tend to have a opportunity cost involved in it. Not only this is one of the reasons we have an there is a lot of manual data intervention at a particular end of this particular process. So this give a particular whole task that we have to take up these use cases and try to provide a tailor-end solution for it. Why it matters? One of the slides is the particular, is this use case is relevant to the particular utility industry or not? I feel so, because these are the 3 points which I come into mind while doing this project. It enhances our customer relationship with the consumers. Every consumer have a credit score designed using, we get a probability score that converted into credit score for each consumer, and they define it whether how they have been behavior towards NPCL. So we provide a tailored solution for them, their tailored customer care or over through IVR and call chatbots. We have to try to provide operational level inefficiencies, automating most of the workflows. This is what I don't want to get into too technicality, but this is a simple framework which we followed in accomplishing this particular project, not getting too into what particular models and this. A traditional simple machine learning model framework is followed. We took up the data, identified the problem, what is the key bottlenecks, key problem areas for the particular team, department, and to the company. We pre-process the data. Pre-processing computes of imputation, outliers, anomaly detection, such that. Then we use feature selection. Most of the features, features mean variables. Most of the variables we find that which are particularly contributing to the model or not. Those selected high-end models, features we selected. We tend to make a model selection. How we make our 10 to 12 models based on various hyperparameters, and tend to find the particular model which benefits which directs our use case. We then have an evaluation metrics for it. Since it is a classical classification problem, we use F1 score as our evaluation metrics. Every month, since billing has been done, we try to monitor the particular model, how it's performing, and not only that model, but other models which we have developed, whether we have particular models over a particular time has improved or not. If not, we try to improve the model data or use hyperparameters more. Then reportings and analytics, which we generally tend to what sort of credits have been going on, how many consumers have paid on time, how not, what particular fold tasks we can do, what prescriptions we can be made here. That all output is installed in SRP ERP system, and then we tend. these are some of the challenges I believe most of you faced in these challenges when the data, when you're working in a cross-different team, the data are in silos. So one key solution for data in silos is to design a particular workflow, keeping in points of all the checkpoints where the data is, taking every member as a stakeholder to the particular data, design a data governance framework for that, and the solution for data in silos will be immediately be resolved. Again, since it's what a classification problem, we have a high and balanced data set. We use oversampling, undersampling, smart algorithms for, I hope it's fine. Yeah, sure. Since we are getting into a large amount of data, we are trying to move, have a data lake and data centers for that particular end. So data integration and management was one of the key challenges which we will be facing. And I hope this particular challenge is also being targeted by all the use cases which we have. So while doing this project, we have, these are the key takeaways and recommendations which we have made. We have reduced the temporary disconnections for the consumers. We have increased commercial recovery, operation efficiency in terms of automation of workflows of each stakeholders, accurate risk assessment of all the consumers. We have integrated it with our ERP SAP4 system. When a particular consumer comes to our center, we get to know the idea of how the consumer has behaved through a simple credit score. We have developed data-driven strategies for social media awareness and everything. We promote consumer awareness, and since it's a machine learning algorithm, we are scaling for the future growth. I hope this is. Thank you, everyone.
Thank you so much. Now I request Amit Kulkarni sir to please present his use case. Sir, I'll interrupt you when the time is out. Yeah.
Yeah, because sure, no issue.
Sure.
I will try to keep my time as per your schedule.
Thank you.
Very good afternoon to all of you, and first of all, let me thank the organizers. There is bit change in the title of the presentation on the request of the organizers as to how they wanted me to cover the broader aspects. So instead of just focusing on some smart grid aspects from transmission, I had tried to cover transmission, distribution, RE and grid operator perspective as well. So the title is AI ML application for transmission, distribution, utilities, RE and grid operators. So everybody is talking about AI, ML, etc. But let me tell you, we should use only one term, AI, because ML is a type of AI, and whatever further deep learning, etc. and different types we have is subset of ML itself. So we talked about data from the distribution utilities and data for DPRs, etc. But just see what the data we have and what we have to say about all this. Almost 64% of the CEOs globally in energy sector agree that there is a need of AI, ML to be adopted, which gives an edge to the business, and 48% agree that it will give return on investment within 3 to 5 years. So what is the AI ML market? More than $190 billion. As far as transmission segment is concerned, this synchrophasor systems, which is considered to be a next generation or a grid eye, is having deployments over 10,000 places globally across all the utilities, and they are streaming the data at very faster rate, multiple times a second, 25, 50, 100, etc. per second. So just imagine how much data is really big data we are talking about and dealing with. Then if you talk about, since everybody is talking about RE and all that, just take one example of wind turbines and the kind of wind turbines population we have and the kind of data they generate annually, just wind turbines, 400 billion data points. So add to it EV, RE, VPPs, SCADA, automation, protection, then your substation automation system, asset management system, ERP system, and all. In short, in nutshell, the big data, use data, what to do, nobody knows. And everybody talked, and in many sessions we talked about metering. In India, we have 2 crore 34 lakhs meters installed, smart meter we call. But many of you have talked about what to do with the smart meter data. Let's focus on other aspects. The energy giant in Europe, E.ON, talks about their experience of using ML, which says that after implementing ML in the system, they could reduce the outage by 30%, which is definitely an added advantage over the traditional things. How it works? A basics been given. Deep neural network. There are on the left hand side you have power system parameters with neural network, hidden layers, etc. You have an output which talks about secure, insecure systems, etc. On the left hand side, I try to give many of the AI ML techniques. So which one is to be chosen depends on the way you want it to be used for the type of objective you have. So it is very important to choose a type of technology or a technique to suiting your objective. That is very much important. Then below the right hand side, there is a deep neural network based online security assessment which we can do. Now some use cases across the globe, as it was asked by the organizers to talk about the use cases and relevance of the topic. So there are ample, at least there are 50 to 70 applications world over on AI ML which the utilities are using in their day-to-day activities. Out of that I have just given some of them. You can see that it's from RE to data forecasting, RE forecasting, even ESS, that is energy storage siting, and understanding where should be the energy storage and which will give you a planning edge to a planner or a utility. That is also covered. So the question is, if you ask me as a working professional having a knowledge of both the domains, I say neural network, deep learning and the power sector, how to go about choosing how to go about accepting the technique or technology based on AI ML. A very simple principle, very famous principle, good, bad, ugly. So the good solution which is solving your objective, use it. The bad one, ignore it, and ugly one, use it with a caution. Now, from distribution, transmission, microgrid markets, energy markets to grid control, I tried to show in one slide how it can be used. So first one is the decentralized distribution system. When you have centralized and decentralized compared in the first square, upper one is a centralized, below one is a decentralized, having multiple microgrids. So when here have microgrids, self-sufficient grid which is said to be with a generator, load, energy systems, storage systems, and controlling and protection devices. How to do it, how to relocate the power and repair and maintenance crews, energy system, storage devices, where the requirement is when there is a outage or a fault, all that can be decided based on AI/ML techniques. Then comes the market operation, the pentagon kind of a thing or a radar plot which you can see is a radar plot of a electricity pricing forecast which has been used by 5 major power markets in the world, right from Nord Pool, which is very oldest one, which is largest one is the PJM in USA, which is very complicated as well, and the European exchanges, that is Germany, Belgium and all. They are using it. They use 2 methods. One is a lasso and another is a DNN. And what was the outcome of using this for energy pricing forecasting is that DNN is better, but it is costly as well. So when you need to choose the method, it is very much important to know how much it costs. Just for the sake of benefit, you cannot go. Now coming to the use cases, we have smart grid implemented with PMU's data. You can see a 400 kV disturbance happen, and voltages dropping and current rising as a typical feature of the disturbance. So how AI/ML technique can be used for such type of instance? What we have done, and our principle is keep your solution simple and having more or a global solution. So we are not gone for any complicated AI/ML technique, though there are many. We are gone just to test the AI/ML with basic things like what it could give inference to grid operators sitting in the control room. So what we try to understand, though I have shown you just, it is the same disturbance which I talked about with the smart grid technique VAMs. For box plot and correlation and clustering, everything we have done, but because of slide limitation, I cannot put all. I have just given you, shown you the two box plots. If you can correlate it with the previous one, you can see the voltage dropping, the same is been shown here in this box plot. And as far as correlation analysis using synchrophasor data is concerned, you can have correlation of different 400 kV and 765 substations which we have in our system. What we have done, for different instances, different disturbances, what the correlation between different parameters, power system parameters, which we see, we have tabulated and try to have an inference out of it, which proves to be as a very good insight to a system operator who is very novel while managing the grid as to if the outage or a tripping of a line or a generator or a transformer, what would happen. So if you have a correlation kind of information like this, let us say 400 kV substations are shown here with different names and their voltages as shown in a correlation plot. So there are 8 substations and their voltages of B phase and C phase is shown. If you have a correlation between different geographically dispersed substation and their parameters and a line connecting them, then you can have a correlation like whether they are those two locations which are dispersed are properly highly correlated, extremely correlated, poorly correlated or disassociated. So this inference we can have as a case study, and later on what we can have. This can be further extended to clustering also. So we have done that exercise as well, though not included. So the basic information on clustering can give you very good input when you are devising your emergency control schemes like islanding. When you need to decide, if you call about a successful islanding scheme in India, it's called to be a Mumbai islanding. It operated 91 times, but in recent past it is failing. So if I have to decide as to whether Mumbai and Mumbai islanding scheme with Tata and REL, if it has to operate satisfactorily, I have to decide about its splitting of a system. And if I need to decide about a splitting of a system, I need to understand based on the clustering, based on machine learning, where to split. So this inference I can have, and I can use this as well for system integrity protection scheme. So in short, this is the last slide. So what we can use, I think the best application is for load generation forecasting, which utility person or an Indian perspective we should focus on, which will give a value added input information as well. Next one is improvement of your DSA tools in control centers, then classification of faults and taking corrective actions. In short, artificial intelligence and machine learning will bring edge to your working, only it is important to know as a human being how to use it intelligently with our brain. Thank you. Thanks a lot.
Thank you so much. Now I request Sumit Gupta sir, who's CEO Asset Plus Consulting, to present his use case.
Good evening, everybody. I hope I'm audible to the last. Yeah, I think probably we have been listening and being over here for last 1.5 hours, so a little tight, but I'll keep this particular session is more about the experience which we have been doing with Indian utilities and the global utilities, and that's where this is, actually we were born out of Delhi utilities, BSES, Rajdhani Power, BS Yamuna Power. We find them as a part of an incubation where we born out. I am ex-McKinsey, ex-PwC, and with last 26 years of journey in that consulting world, one fine day, 6 years back, I left. And that's where we started with the part of this journey wherein we went into the BSES Yamuna, and then we talked about the use case of what is utilities grappling with today. If you look at national utilities or international utilities, both are grappling with the problem of revenue protection, revenue assurance. And that's the biggest problem, and that's what we're looking at. Even smart meters being looked to achieve that first. And that's where, when we talk about these kind of information, we have to collect a lot of data. And this data, we all have talked about the data part of it. But the biggest perspective, if we have to look at any transformation to happen in a utility scenario, it is just not one data, it's a multiple data set which has to go in. And that's where we had to create a kind of a lake of data to look at transformation, not one perspective. And that's what we did this exercise in the time when nobody was thinking about this. And I'll tell you the part of dates, you will get surprised. And this is where we tried to bring in the combination. Husband, wife start this entity in 2018. She come from Microsoft, I come from McKinsey. That's where M Square combined together. And we look at part of technology as a top and the domain experience. This domain experience was vital and killing for us to understand, because we knew where the problem is happening in Indian utility. Be it part of private utilities, be it part of my government utilities, where are the problems in? Today we work with Sabah also in Malaysia, and thus we solve them the part of the revenue protection, revenue assurance, and we tell them where the problems are happening. Now look at this. This was the first data lake project in India. 2020, we were not thinking about AI, machine learning, nothing else. This was the thing which we went out to the part of BSES and told them this was the first Indian data lake project happened in power sector, and it was being successfully implemented in 2021. By that time, nobody was in fact talking about these things. This was done. Why? Because we come from sector, we knew about the problem, we went in. What we did, I'll just try to look and show you in this particular next. Now, while we have been delivering this, the journey started in 2020-21 with the part of two sister concerns in Delhi. It went out to the part of ministry project in Jaipur in 2022-23. And right now we are engaged with one of the biggest, largest state of India. 3.5 crores consumer, Uttar Pradesh. And we are doing a transformation for them where in 2 months we brought their AT&C down to 1%, 12% to 13 to 1%. This is kind of phenomenal thing happens when we try to understand what are the interventions, how it has to be done. This is the certificate from MOP, which gives a part of what the achievement has been done in India, in the state of Rajasthan. So what I'm going to present to you is actual thing right now being used and has been used since 2020, the time when we have implemented it for BSES Yamuna Power. And I really recommend, it's BSES, both the entities, RPL and we have done thousands of use cases with them. Now, what is the biggest challenge if we look at for utilities? One at the end, we look at us, there are poor meters, there are billing inefficiencies, there are deviation of energy. In the scenario when we have got digital meters to look at. Now, in these cases, there are meter readers nexus in terms of how they are taking the reading. There are misuse of tariff where the people do it. People take domestic consumption, they use it for commercial, right? You would have seen them. They stay in the first floor and they drive. So that's where you have to look around how to look at the part of this. Second thing is, my dear friend from NPCL talked about the part of the defaulters. This is what was done in for BYPL in how to look at my commercial improvement. When we look at my commercial improvement, it becomes the part of what we call AT&C in Indian context, aggregated technical and commercial losses. Global context called revenue protection, revenue assurance, which you look at, right? We talk about it whether in so this kind of problems there in down the countries below the equators, like in Asia Pacific, if you look at Africa, North, South America, more problems on the part of revenue protection comes in. And that's where, when you look at part of at the meter, I will have multiple type of meters being there in the utility. Static meters, go to the part of the eastern states utilities, there were static meters. Down south, the largest state has got static meters, 40% of them. Then there are digital meters, and now we have got smart meters, ample of them. There are ample of smart meters. Now, the biggest challenge is, none of my substations is completely on smart meters. They are still the part of digital meters, some of them are static meters, some of them are on smart meters. And my CMD wants to know, MD wants to know what is my AT&C reduction happening here. And then what happened? Somewhere we do manual activity, somewhere we do the part of a system-based activity. This is where we brought this platform called LR+. So now if you look at, now there's also part of one more thing called meter. Now this meter, everybody out here like Tata Power, Western or Noida Power, BRPL, And within Delhi, we have almost around close to 2.5 crores. We have around 80 lakh consumers over here. Now, in these consumers, we can't see the meters and say which is a meter is poor condition, which is a meter is good condition. Today, this particular thing has been done by almost 30% of Indian utilities use this meter analysis to find out which meters are correct, which are wrong, poor conditions, is a poor meter condition. And once we are able to do this, it's called billing efficiency improvement, called loss reductions, LR, which is called protection part of it. This is one element. And the second element comes in part of after the meter collection improvement. This is the exercise as a part of my McKinsey report, which it produces. In India, there is only 40% of collection happens at the due date. Remaining 50% happens after due date, 5% is the delinquency in the different part of thing. And when you look at part of these numbers, they vary. And when we did this part of a transformation for BYPL, right from the part of they have got around 1,000 crores of their turnover at that point of time. When it started in 2020, there was only 30% realization happening. And that today also they use that. It's been last 5 years. And there today realization is almost gone up to 80-90% before due date. So look at part of the unrealized interest gain. Those people who have a finance background, they can look in part of. So this is what is collective means become the revenue protection, revenue assurance. In India, we call it as a part of AT&C loss. Where is this part of commercial aspect? They got technical, we look at part of the line losses which is coming up. Now, in order to do this changes, this requires a lot amount of data over it. If you can see in this part of thing, this side. So what was being done? And in fact, if we look at all the utilities, we have got domestic consumers, would be single phase, could be three phase also. We have got commercial consumers all on MRI basis. We have got now AMI based consumers also coming at both the levels, which is by my domestic as well as my commercial, this thing. In such a scenario, each of my meter has a different protocols, different mechanism by which they basically communicate. So now look at this part of. There is CDF based format, EMD based format, text based format, that depends on which meter type it is. And that's where we have been ruled by the part of meter here to bring in a part of what we call as something in between to look at BSES, which is called the converters. This was in 2020, we created a model which can convert each of the data formats from the meters and try to take into the system. But while we are trying to take this data, it is a humongous data. Now, all of you from utilities, you look at one particular file which has been read by the meter, it will contain the past data also. Now, that past data, if you are able to look at the systems, becomes a huge chunk. Every day file becomes, every month file becomes a huge file. And that's the way we brought in part of something called, that point of time, Hadoop. Hadoop, native Hadoop. This was been done at on-premise. We told BYPL not to go for cloud Hadoop. We will look at part of your machines which have been depreciated to the zero value. So this is where comes to the part of consulting element of financial aspect. On-premise Hadoop, native Hadoop was being created, my dear friends, and within the part of 6 months, this particular architecture which was being put in Hadoop ecosystem where all this fine data which was being put it converted into the part of one format, XML format, so that my system can read it. And then from that, it basically went on to look at something called, now there was a question of kind of, I'll just take 5 minutes with it. Just point of descriptive analytics, which is purely point of how my condition is. Other is part of what Vadhva Sahab was talking about. Can I system can tell me what is the access? Today, prescriptive analytics takes a part of it and tell me what has to be done. And AI, ma'am, you're saying that AI will require clean data? No, it requires garbage. That's why today the AI requires, it tries to train itself and say which is the process correct data to be used and make sense. Remaining garbage tries to send it back to us and say analyze that. This is the power of the system which tries to look around. And if you look at, this is where the SDFS lake was being created, and then all technology are not getting to that part of it. And then all the format of XML, all different kind of meters makes me look at. Today's scenario, we talk about part of Manila utility, so on those kind of different kind of meters which they have, right, in Sabah. Now, what was being done as a case study on BRPL, people talked about the algorithms. I'm not talking about algorithms which is there, but there's XGBoost of this. What I'm talking about is, what makes sense is how you are able to arrive at control parameters and relations. And that kind of chain, if you are able to analyze, this is where you can be part of events and consumption correlation. I'll give you a classic example. Today in digital meters, you cannot look part of where the consumers are having theft. When we're doing it in Rajasthan, on part of smart meters, what happened? You get a neutral, there's an earth leak event happen in your system. If you get an earth leak event happening, that means the neutral is imbalance. Now, neutral imbalance is coming up regularly, that means there's some problem with the part of your wiring. But if there is a neutral environment happening sporadically, specific time, and that point of time, you look at part of your loads which are coming up from your smart meters consumption load profile. Try to align them. You find wherever that particular block, there's a spark. There's a rise in the part of current. That's the place where the hooking has been done. We trained the model for hooking in a place which is called number of 48% hooking happening in Bayana in Rajasthan near to Bharatpur World Century. And next time when the hooking was being made, we were telling the vigilance team, go and see, check there, that's the person doing the hook. This is the way ministry gave us that part thing of the outcome, which was around 68 to 90%. The first we train the model to become 90% by the time we finish the project. So that's the kind of thing which happens in the list comes in like this to look at how the outcomes are. I'm going to show you something else. This kind of model parameters we look at of our metering conditions. Now this is the way the more evolved. Today we look with Madhyanchal. That was 2020, this is 2025, the new picture. You look at part of direct theft, consumer, which are bypassing the thing, bypass the road, that means completely bypass meter. This parallel consumer, somebody use service parallel, half load, half their time bypass. And other are misuse of tariff, I was telling you. How do you know about from the same digital data, meter data you find of them? I'm talking about smart meter will tell me these things, I can have, but for my current meters which are there, my non-digital meters, which has to be digital meter, non-smart meters. This is what being done today to look around. This is on the part of smart meters and the MRI-based data where they're trying to get to the modeling. Today, MVVNL, you heard about the Sambhal case. Somebody was picked up, we predicted out the theft, right? So that was the kind of thing. Now look at this. This is look at part of your all kind of meter data, be the image, be the part thing. And this is, I'm just trying to scroll through. We get the list of suspected consumer. This goes into the part of location where they are, so people get to know. In utility, ma'am, you all are over here, nobody gets a part of list to go on part of raid. They go by the part of somebody's name. Today we have a list which has been given to the utility guys in, yeah, done?
Yeah, I'll have to cut
This is the way
you.
the app goes in, and this is all driven by AI ML principle, the back end. And look at this part of it, the person's caught, coming in over this theft is. This has been able to produce the list for field verification. Last slide. This is helping consumer indexing, energy gap between the feeder DT consumers, real-time service parallel bypass, enhancing billing accuracy and revenue. The idea is that this is trying to bring you a collaborative data into one platform to be processed, because this thing cannot happen by one data. It has to be all kind of meters, all kind of outages which have been put together, and that's the reason why we require a data lake. Any kind of transformation we're doing at your end, think of a data lake, because that's where today you have a structured data where you can run machine learning. Machine learning cannot be learned a part of a simple unstructured data. When you look at part of tomorrow, you are adding the part of an IoT streams of information coming up. Third, you may have your images coming up. Your data lake has to expand, because I don't want to think about the part of databases to be created over there. So think from that, right? That's my recommendation to you. Thank you, everybody. Thanks a lot.
Thank you, sir. Now I request Vishaka, from who's product manager Impresa.ai, to share her use case.
Hello everyone, it's my pleasure to be here among the brightest minds in energy industry. Disha, you are doing a brilliant job at this. And Sumit sir, आपको mic की बिल्कुल ज़रूरत नहीं है. अब mic नहीं होता फिर भी last तक आवाज़ चली जाती है आपकी. ठीक है. So let me start with asking you all a question. Can you guys imagine a scenario where, you know, energy theft is detected moments after it is happened? Outages are predicted and prevented, and every watt of energy is accounted for. Looks pretty interesting, right? Yeah? Can I get a yes, please? Great. So now imagine the opposite, right? Where anytime a transformer goes off due to, let's say, overload, you don't have the relevant data, you cannot draw insights from them. You have billions of monetary losses due to billing efficiencies and all the other efficiencies, right? So here's what at stake, right? We have 1.2 lakh crore loss annually due to theft, right? That is almost 25%, right? Only in India, right? Where the world is at 6 to 8%. So we are pretty high on that. Then we have 40% of outdated transformers that cause grid instability, right, which is also impacting a lot in renewable integrations. we have 500 gigawatt of targeted renewable capacity by 2030, right? Which requires smarter planning tools. And finally, we have a targeted of 250 million smart meters to be installed, out of which we have 8 million meters already installed. So these are the problem statements at hand. And what can AI do for this, right? With AI, you can reduce and cut theft by almost 30%. You can extend the asset lifespan by 30%, extend it. You can fix some legacy data gaps, right? Achieve a more better network hierarchy. And finally, you can have AI-powered data analytics that can unlock billions and billions of insights. So this is where we come into picture. We are Impresa Insights. We are a utility-centric data platform and AI platform. We have a unified utility data model. We take in data from multiple legacy systems, be it hidden systems, MDM, GIS, SCADA, right? And we unify it in a centralized data source. We also have real-time insights. Since we are bringing so much of data, right? We have real-time insights where you can tap into the data coming from all these different sources, and you can utilize them to perform real-time decision-making. We also have scalable and flexibility, right? Be it 1 million meters, be it 10 million meters, be it 20 million meters, be it 100 million meters. We can do it pretty easily, right? And finally, we have a multi-model delivery. We do not only believe that we can give you probably reports or dashboards, we can deliver the solution and insights, be it in reports, dashboards, mobile, or any particular interface, right? So that's what Impresa Insights is about. And I have talked about a lot of fairy tale, but if we come, okay, can you please help me with this? So I've talked quite a bit about, fairy tales that we can do this and that, right? But if we come to the actual scenario, right? These are a comprehensive suite of AI-powered deliverables that we have already done at one of the largest utility in the Middle East. These are a dozen, almost more than a dozen of solutions that are already available, deployed, and are in operations for this largest utility in Middle East, and there are a dozen in the pipeline that are going to be delivered in the upcoming roadmap. So we have load forecasting, demand forecasting, we have load disaggregation, we have peak load calculation, and all the other multiple solutions. But I'm not going to dive in deeper because we already have a cap time. But if I go, we can probably discuss about 3 to 4 use cases, right? One of the very interesting use cases that we have is AI-driven source of supply. We all know that there is a very big gap in network hierarchy, right? We don't know which meter is mapped to which transformer, what transformer is mapped to which feeder, which feeder is mapped to which substation, right? So we try to help the utilities building up this network hierarchy, right? We do the mapping of meter to specific DTs using our AI module, and we have already implemented this both in one of our Middle East, both in the rural area as well as the urban area, and we have successfully done this for at least 2 million smart meters. Then we have load disaggregation. Load disaggregation is a very interesting use case. It's completely data-driven. We do not believe in sensors. We do not believe intruding into the house of customers, right? We have a completely non-intrusive load monitoring solution where we take in data from multiple legacy systems, HES, MDM, right? And we deliver the breakup of different appliances and appliance categories for those customers. And I'm also very proud to say we are currently live for 10 million meters in the Middle East utility for this solution, and continuously are generating results for energy disaggregation for these 10 million meters. Another, we have the energy theft detection. The first point that I started with was energy theft, right? We are losing a lot of money in theft, be it non-technical, be it technical losses, right? So we already have developed an algorithm, and I'll deep dive into this because this is particularly very, very specific to India. And we'll see a couple of slides in the subsequent content. But we have developed an algorithm that can catch not only energy thefts, but other non-technical losses as well, be it grid issues, be it faulty meters, and whatnot, right? And then lastly, we have transformer monitoring. So this is sort of like an ecosystem, right? One use case can help the other can help the third can help the fourth, and this is like a complete ecosystem, right? Transformer monitoring can help in identifying overloaded transformers, underloaded transformers. It can help in predictive maintenance. It helps in asset insights, right? There are multiple use cases revolving around this, but we have built multiple solutions specifically for transformer use cases specific to grid planning. And if I move forward, let's talk about this ecosystem that I was saying. So this is the ecosystem in action. Let's think of this as a cohesive solution, comprehensive, all stitched together. Let's say we are a utility, right? And we have issues with our network hierarchy. We don't have mapping of which meter is linked to which transformer and all that, right? So we build up the mapping for meter to transformer at the first level, right? And once we have these insights, we can use this for energy disaggregation. Now we know which meter is linked to which transformer, what is the load capacity, whether the energy that is being disaggregated, is it the correct input that is coming or not, right? Now we can disaggregate probably how much individual appliances are being consumed by the different consumers, right? Now that we have disaggregated, right, we can use this insight for energy theft. Let's say we know that this customer is using this much AC, so this much high load is expected from this customer. But still, why is his smart meter readings very less? Why is there a lot of less power being consumed? That is pretty suspicious, right? So it can help. It can provide inputs into energy theft as well. Right, so like you're saying, right, all of these use cases are interconnected, and it forms like an ecosystem, right? We are creating an AI ecosystem in action where one use case helps the other, building a comprehensive end-to-end solution. And now that we have done energy theft, right, we can move to transformer monitoring. We know what energy thefts are happening. We can identify then, let's say energy theft is happening at this particular transformer, even though it's not capturing as much as is shown in the data, but it is overloaded, right? So there are multiple use cases. Likewise, this is just one scenario that I'm talking about, but you can build a comprehensive end-to-end decision-making life cycle with this. And again, this is a continuous loop. You provide the AI with the feedback, and it's in a continuous iterative cycle where the system just gets better and better with time. I hope it sounds interesting. Yes? All right, now since I was talking about energy theft detection, right, this is our dashboard. We have the panel where you can see the standard asset information. We have the map view, and we also have a heat map which targets which are the most impacted areas where a particular theft is happening, which are the less impacted areas, right? We also have the insights based on region, right, where the majority of thefts are happening. And finally, we have the different types of thefts being identified. So let's say it's not only just thefts, let's say multiple types of non-technical losses are being identified. But what sort of non-technical losses are being identified, right? Is it a theft? Is it a grid issue? Likewise. So we also provide root cause analysis as to if a particular asset is tagged as anomalous, why is it anomalous? Moving forward, we also have a drill down and breakup of, let's say, a particular asset was tagged as anomalous. They can go and probably understand it as well. You can have more in-depth analysis on the same as well, right? There you go. You can look at the current analysis, voltage analysis, power analysis for the same, right? And there are multiple factors. We have a big drill down, but it was not going to fit in the screen, so I have not included it. And finally, we have one of the use case where this is an actual theft case identified in the field. And where you can see here that we have phase voltage drop with current present. That is, there is no voltage in the one of the phases, but current is present, which is absolutely abnormal, right? So accompanying with this, we also have a tamper event linked to the same smart meter. So this is one of the types of energy thefts that we identify. And I would also, yes, I would like to highlight, every day we are running this for the utility for 10 million meters every day, right? And every day we are identifying 3,000 to 5,000 anomalous cases. So this is a live system. It's completely alive. It gets feedback. It keeps on evolving, and there is always going to be improvement. With time and time again, we're going to just evolve. We're just going to identify more sophisticated and complicated thefts. But 10 million meters, that's not bad for a start, okay? I think that's pretty much it from my side, and thank you very much.
Thank you so much. Now, I think this is the final presentation from Mr. Dimas. I request you to please share your use case. Thank you so much.
Okay. Good afternoon, everyone's respected chairmen and distinguished speaker. Thank you. My name is Dimas. I'm from PLN, a testing company from Indonesia. And today I'm going to deliver about our use case in PLN that have already developed. It might be in piloting, but some use case has a plan to be scale ups in the next few years. Okay, so we are, PLN is vertical integrated company. So we have some from primary energy to provide electricity with coal, natural gas, and biomass. And also that we have generations, transmission, distributions, and we manage more than 80 million customers. So with those diverse line of business, we have challenged that we have some of energy cost volatility, supply chain disruption, and the rising of load demand. So that's why that we need use case, especially in AI, to promote. And also that from our past challenge, we already have make some pestle analysis to make some evaluation of the external factor. So we have some, for example, like politics, we have supportive government's policy, economic, cost implementations, efficiency, social, with digital literacies, technology. We need to integrate AI and accountability, and we need to consider about the infrastructure readiness and with the environmental and legal. So we also consider about the private data protections. So since that we have collected so many use cases in PLN, more than 60 use cases, so we have to prioritize which one is use case to be developed. So there are some key enablers. Yeah, first about data infrastructure. Of course, that we need a smart meter and IoT device to collect more of the asset data informations, and we need advanced analytics to collect, to manage the big data, yeah, to support the driven foundations. And it is final investments because using use case AI, so that's why that we plan to build our AI labs, yeah, and also that we still need to consider about cost benefit analysis. And of course that since that AI use case is diverse, so we need to upskilling our human capital. So that's why that we also collaborate with AI expert to have more insight to accelerate technology adoption. And last but not least about cybersecurity network. So since that we adopt the data protections, so we should consider about the resilient infrastructure. So that's why that in our generation transmission, we consider about to OT security networks. So since that we have some many use cases, so we should make prioritization of AI use case. And since that right now that we are having a roadmap, smart grid roadmap end-to-end, so we need to make some short list here, which use case to be developed based on our corporate needs. So since that we have like generations and transmissions, distribution and retail, so actually we have some short list use case that are going to develop. For example, generation, we have soot blower optimization in thermal power. We have predictive maintenance based on historical informations. We have hydro assistance in hydropower plants and heat exchangers. And in transmissions, I know that some of our colleagues have already talked about demand forecasting, And we consider about smart vegetation management as both transmissions for monitoring systems and distributions. We start to discuss about dispatch optimizations. We also consider about intelligent distribution solutions for smart distributions. And we just start to initiate the OCR for the meter reading, load prediction for electricity consumption, and a chatbot in our PLM mobile apps. Since that we have so many limited time, so I think that I'm going to prioritize to those two use cases. This is about the hydro assistance in hydropower plant and smart dashboard emission monitoring. So based on our lesser experience that we already prepare for use case for to propose to the WEF digital lighthouse. So the first use case actually that since that we have some hydroelectrics which is operate before our independence, so it's like more than 70 years ago, and the system should be cascading. Yeah. So for example, we have some 4 generations and we have some terrain, geographical condition, and it is like run-off river. So for example, that in these ideas, how to our use case to be aimed to organize the inflow of water from the top part to the down part. So for example, that the system that we collected, we get the informations from the smart sensor that installed in the top part of the dams in the hydroelectric plant, and we also get the information from the weather forecast, and the asset data information from weather forecast and from the current inflow, which is captured by the sensor, is go to the database, and using database, it is processed using machine learning model. So that's why that we can get some informations of predictions and estimation of the model of data modeling of the data inflow of water. And the inflow of data modeling of inflow of water, and also that in the predictions will be displayed in the database or will be displayed in the dashboard, which can be accessed by the operator in the substation, in the generation. And when the inflow of water is larger than the optimal setting, so it will send the push notifications to the operator so that the operator will make some risk mitigation. For example, if the inflow of the water is larger than the optimum setting, so the operator will organize or adjust the hydropower plant. So for example, they will increase the generator setting. And for example, if the inflow water is under the setting, so they can also adjust the hydropower to be minimum load. The second use case actually that we developed the dashboard of the transmissions. So what we're trying to do is we develop the health model based on our historical of the corrective maintenance work order. So actually that we are using the enterprise management, and we just collected based on historical information. So what happened here that we use a Gini of 92 to is able to predict 80% of the failure is caused by the 20% of the asset itself. So we use the data for the past of 5 years, and 75% from the data from 2019 to 2023 is trained, and we can get the 25% is testing. So that's why that we can get the health model, based on the group, based on the work order. So we can learn about the relation between the input and output of the corrective maintenance. So for example, using this insight that we can evaluate in which area or which tower should be considered, because if, for example, like the green one, it should be like secure area, and the red one should be needs to be considered. So by having this one, that it can help the maintenance teams to do some optimization in the CapEx or their OpEx maintenance.
Okay, so this is the last slide.
And the takeaway points that digitalizations in the PLN is still undergoing, and we need to prioritize which use case to be developed first. And by identifying the right use case, I think that should be the right decision, yeah. And also that PLN need to employ AI capabilities, yeah, to pinpoint the perform asset inspections and preventive maintenance, and using the data-driven insight, hopefully that we can develop decision support system. Okay, I think that's from us. Thank you.
Thank you so much. I think we have over our time. So if you have any questions related to with any speaker, so all of them are around, you can directly ask them or maybe like that. Okay, you can like all the speakers are here only. After the session, you can just ask them. Yeah, so we'll be closing this session now. So I'd like to thank everyone for presenting their use cases, and there were different type of use cases with different technologies. So it is really wonderful that nobody is working only on one sector. There are different sectors which you are working on, and we are not only thinking about utilities but also prosumers. So that viewpoint gave us a confidence that we have a bright future ahead in AI, ML and robotics. So giving a round of applause to everyone that we are doing a great work in this sector. And in India, like they say that we are, like we follow other countries, but I can say that in AI, ML and robotics, the other geographies will follow us. So cheers to that. And now I'll request our Executive Director, Ms. Reena Suri, to please felicitate all the speakers and our chair. So I request Reena ma'am to please felicitate Ms. Kiran Gupta ma'am. Ma'am, we'll take a picture over here so all the speakers can come here, and then we'll take a group photo. Sorry? Yeah, I'll keep taking names. Then Praveen, Kumar, Goyal sir from NPCL. Murthi sir, additional VP BRPL. Kumar Pabbineedi sir from PGCIL. Yeah, Anil Ojha sir from Tata Power Odisha. Deependra. Yeah. He's Anil. Yeah. Now we have Deependra with us. Yeah, he was, sorry, I stepped ahead. Aftab Alam sir. Next we have Vivek. Amit Kulkarni sir. Yeah, I request everyone to please stay back because then we'll have a group photograph. Sumit Gupta sir. Vishaka. And Dimas. So I request all the speakers to please come in front, and then we'll take a group photograph.